All right, although the PowerPoint tells us to skip it, we're not going to. The character class is another wrapper class. It's a wrapper class for the char, the char data type. And it's got some cool functions in it. If you've taken Python, you'll remember that we had the isDigit or the isAlnum type functions to check to see if something that they typed was a digit. Is uppercase, is lowercase, that kind of thing. We have the same option to check character by character in a string. So, this is going to be silly, but it won't take long to demonstrate. We're going to let the user type in a string, and then we're just going to print it out, replacing all the digits with number signs. All the letters with, I don't know, underscores? Asterisks? Yeah, let's do asterisks. Or question marks would be kind of cool too. Let's go ahead, pop open NetBeans, and then we're pretty much done with this chapter. We will move on. Create a new project. Be sure to go and add java.util.scanner. I always remove the package statement and then fix it. Fix the warning that says incorrect package. Move class to correct folder. If you're using TextPad to edit or whatever, you don't need to do that. And I'm going to add import java.util.scanner, capital S, just so I have it ready because I know that I'm going to need it soon. Now down in main, ask them to enter a sentence. System.out.println, enter some text. Let's let them do that, but I haven't made my scanner yet. I always forget to do that, so above that line I'm going to do, not scammer, scanner sc is equal to new scanner system.in, just like always. I'm going to delete that comment, but I recommend you leave your author comment on your own. All right, now I'm going to read it in. String text is equal to sc.nextLine. Why am I using next line? I want them to be able to type in a whole sentence. Now let's enter a loop. Let's get all the characters out from beginning to end. For loop seems like a good idea to me because we're going to start at 0 and we're going to go out to the length. So for int, and I like I for index, is equal to 0. I is less than the length of the string, so text dot length parentheses end parentheses I plus plus. Now if you remember the array, no, we haven't even talked about arrays. Never mind. Length is indeed a method, so you have to put parentheses around it. Now let's get that character out. Char ch is equal to, now how do we pull a specific character out? How do we pull out, for example, character 0 out of a string? We saw a function that did that. Char, right. So char ch is equal to text dot char at position I. Now we can play with that. If it's a digit, let's print out a number sign. If, and of course you have to put parentheses, character, the whole word, dot, is digit, and then we have to pass in that ch. If it's a digit, let's just do a system.out.print, not print line, a number sign. Then we may as well do an else if, in my opinion, because it's either a number or a letter. It's not both. So this one's going to be character.is, but it's not going to be isDigit. Let me sneak back to the PowerPoint to see what it's called. Is letter. You can also do is uppercase and is lowercase, but is letter will be enough for our purposes. So else if character.isLetter. Character.isLetter, and then pass ch into that method. And if that's true, let's print out. Never did decide what to make that. An asterisk. And then if it's none of the above, let's print out a question mark. It's like we don't know what it is. Probably punctuation. So lastly, if neither one of those work, let's do system.out. Except it's not print line. I don't want to go to the next line. I'm going to need to fix that print ln on the line above. System.out else system.out.print question mark. And I need to change that last one, that print ln, just to print. Make sure I have my closing parentheses for my loop, and I should be good to go. I should be able to run it. Guess I should test it before I brag about it. So I click hammer and broom to build it. I click the green arrow, enter some text. I'll bring the code back in a minute. This is my favorite number, colon 1, 2, 3, 4, 5, exclamation mark. All right, that looks pretty good. I wish I'd put a print line at the very end. You can see what it does. All the letters got replaced by stars. All the punctuation and spaces got replaced by question marks. And all the numbers got replaced by number signs. Now normally that's about the time after we introduce these that I ask you to write, a password program. Count the number of digits in this. Make sure that the user's password contains at least one digit, one uppercase letter, one lowercase. I may not. For one thing, you do that in every other class. But, like base 1, 1, 1, and 3, at least if you took it with me. Who knows? Maybe we'll go back to it. But I think that's about enough of that. You can look at each character in the string and determine whether it's uppercase, whether it's lowercase, whether it's a digit, whether it's a letter. If it's not a letter or a digit, you know it's punctuation. Anybody need to look at that any longer, or are you getting syntax errors? In this case, could we have used a switch statement? Whenever you have a series of if-else ifs, if you've grown fond of switch case, I'm going to give you the answer, no, but why would that be? Yeah, it has to be an integer type. We don't have any discrete values for these things. Unless we did case A, case B, case C, case D, all the way through every letter of the alphabet, including Russian and Greek and stuff like that, So when you're going to use case and switch, it has to be on an integer type. Now that could be a little bit of a lie nowadays. I keep forgetting whether Java allows you to switch based on strings. I guess it's worth finding out. I'm going to go down here underneath my for statement. I'm going to add a comment saying end for, just so that I know where I am. And then I'm going to make a string. I don't know. We've already got a string called text, right? So switch based on text. In case they typed quit, system.out.println. Oh, you'd like that, wouldn't you? I'm changing that to just OU, so it won't be so long. And then break. The only reason I did that is now I can compile it, and if that gives an error, great. If it doesn't, great. Okay, so within the last few versions of Java, switch has been made to work on text as well as on integer types. And integer types can also include characters, because characters are integers behind the scenes. They're just a number between 1 and 65,000 or whatever. I do want to put my print line there just to be picky after my end for so that the output comes on the next line. System.out.println. That's about enough. Enter some text. Quit. It says OU. Okay, so you can nowadays, in this language, switch based on strings. Some languages don't even have a switch structure, Python being one. Others have it, but they won't allow you to do it based on strings, namely C++. All right, that's the end of this chapter. Let's look at their silly quiz questions. What is the name of the class that contains ABS, min, and round? Is it arithmetic, math, or number? If I want to call it the absolute value of something or get the power of, what do I prefix in front of that method name? Math, yeah. Alrighty, integer and character and double and float and long and all those things are examples of framework classes, hover classes, or wrapper classes? Wrapper classes, yeah. No such thing as a hover class as far as I know. Framework sounds enticing, but nah. They're called wrapper classes. So if you see the word double with an uppercase D, or integer with an uppercase I, or character with an uppercase C, that's a wrapper class that gives you extra functionality for those primitive data types. Integer, int, or double with a lowercase d, or whatever. Just like the char class, the char class, didn't have the ability to distinguish whether it was an uppercase or a lowercase letter. However, character with a capital C, the wrapper class did. If you want to parse your input to turn it into a double, and you call double.parse double, you use a capital D there because you're using the wrapper class. The primitive data type double has no idea how to turn a string into a number, but the wrapper class double with a capital D does. See where we're going with this next. All right, so object-oriented programming. The idea behind object-oriented programming is that in the real world you don't just have single values, a weight or a volume, or a temperature. Instead, you have collections of values. You have a patient, and that patient has a weight, and a height and a temperature. So, when you're in the hospital, they've got a whole chart full of your data that they've entered, not just, one value. Or you have a printer. The printer's got a whole bunch of data associated with it. It's got, the amounts of each color ink or whatever, and how many pages it's got in it, whether it's empty or not. And it's got, which document it's currently working on and which page in which document. Or you can have an employee class where each employee has a name, a first name and a last name and a birth date and a hire date and a termination date and their starting salary and their terminating, salary, and whether they're an hourly or salaried person, and what insurance they have if you're lucky, whatever, So, and then you can have a whole bunch of different employees with different values, each one with a different name, each one with a different birth date, and so on. So we're going to be talking about what objects are, what classes are, and what encapsulation are. And yeah, these title pages, I don't want to just throw a bunch of words at you telling you what we're going to talk about. I'd rather go and talk about them. So, in the old days, the standard programming technique was called procedural programming. The emphasis was on the procedures, or the tasks that made up the program. And that's what we've been doing. Input, the radius of the sphere. Calculate the radius of the sphere. Maybe you did that in a procedure, a function. And on the output, the sphere. So you just kind of mapped it out like that. You would design your program around what you thought were the key procedures. You might write a procedure called get input. You might write another procedure called calculate results, and you might write another procedure called, output results. Kind of break them up like that. So you were trying to break up your code into logical units, but it's still pretty much, It wasn't object-oriented programming. Today, the most popular programming technique, or if we want to use the fancy word, paradigm, so that we could strut about and look awesome, is object-oriented programming, also known as OOP. With OOP, instead of thinking first about the procedures, you think first about the things in your problem. What things are there? You think about the nouns. All right, I have an employee. Suppose you're writing software for a library. The library may need a book class. Each book has a title, an author, a publisher, publication date, which revision it is, what ISBN number it is in case you need to order it again, how many pages it is, whether it's checked out, whether it's on loan, who checked it out. All that information needs to correspond to just one book, and then you could have a million different books in your library. So book is your noun, and then all of those are attributes of your book. The author is an attribute of the book, the publication of it. So the book is an object. Actually, the book is a class, and then each book you make is an object based on that class. And that'll make more sense in a little bit, but think of the word class as meaning blueprint. So you have a house blueprint, that's the class. And then you start building houses, you can use that same blueprint to make 100 houses. Those are each objects that are made from that class. So an object is let's get all technical here, a set of related data which identifies the current state of the object, plus a set of behaviors. Now that's a great computer science definition, but I like to define it just a little bit differently. Here's what I would like you to remember. Now if I ask you what an object is or a class is and you give me this answer, that's fine. But here's how I like to say it. It means pretty much the same thing. A class is a set of data and the methods that act on that data. That doesn't mean that every class has data or that every class has methods. But in general, that's what it is. A class is a set of data and the methods that act on that data. That's the simplified version of this. For example, you might have a class called employees, or customers, or students. You might have cars and a traffic flow simulation. You might have aircraft and an air traffic control. You might have electrical components. You can be sure that when you're playing, League of Legends or some video game and you have characters all running around, that each one of those is a collection of objects. Here's my character and he's a wizard and he has these spells and, that kind of that. You have all this information grouped into one character. If you play Pathfinder or Dungeons and Dragons, you have that idea. I have a wizard, that's my class, and he has these abilities. And then your character is a combination both of that, those abilities and some other stuff. Mathematical entities, you might have points in a coordinate system, an x, y point. Complex numbers, time, where you have hours, minutes, and seconds, and years and stuff like that. So the benefits of OOP, object-oriented programming. Programs are more understandable. Now, if you take somebody who's done procedural programming all their life, like somebody who's done COBOL program or Fortran programming for 20 or 30 years, not that there are a lot of COBOL programmers left, and they do get a nice salary because the art is dying out. But anyways, and then you throw them into an object-oriented environment, like you give them a whole bunch of C# code in a .NET environment, or you tell them to update, a Java application, it's going to blow their minds because it looks completely different than that procedural programming that they're used to doing. And then they wind up going and taking a class or something like that in order to transition into that. But programs are more understandable. People tend to think about problems in terms of objects. Somebody asks you to write in a accounting program, they'll talk about it in terms of, okay, these are my expenses. Each expense is an object. And these are the checks that are coming in. Each check is an object. That's how they think about it. That's how they describe the problem. And then when you get this many checks and you subtract those values from the blah, blah, blah. So, and supposedly fewer errors. Since objects provide encapsulation, here we're going to use a term before we define it, it's harder for the data to get messed up. Now, encapsulation means that you make the data in such a way that that the program can't modify it in anything except a correct fashion. For example, if you have a character in a video game and his hit points can be anywhere between 100 and 0, you can make it so that his health can't go negative. Even if the programmer tries to go in there and change a line of code so that his health went negative, I don't know why you would. A long time ago, I remember playing a game where, if you sold an item or if you bought an item for a negative amount of money, you'd actually get that much money, rather than spend that much money. You could type in, how much do you wish to offer? You type in negative 1,000. Ooh, I have 1,000 now. So anyways, with objects, you can make that object corral its data, manage its data, encapsulate its data. Think of a capsule of medicine. It's got a shell around it. So that the state of that data is in a good state all the time, at least that's your goal. So that you never have a salary that is a negative pay rate to where you're paying to work for that company. I hope that doesn't happen. Or a birth date that, is more than 200 years old. Or that says, some month after the month of December, 14/whatever. So that object can keep its data good. It's harder to get the data messed up. Your object contains the data, and then it contains methods that act upon that data. So anytime anybody wants to change the value of the data, they may have to call a method that changes that data. Set salary. And the set salary method can inspect the input going, no, you passed me a negative salary. I'm not going to allow that to happen. And then the rest of the program uses these methods in order to change the data. That's the idea behind encapsulation. So a class is a description for a set of objects. Here they're going to give us an example of a computer vendor, Dell or something like that, or a conveyor belt in a manufacturing plant. There are 3 computers on the conveyor belt. Each computer represents objects, and then each computer has a list of attributes, which are data. The specifications for that computer. What might you need in order to specify a computer? You might need to know its processor, how much SD-RAM is installed in it, all that kind of stuff. How many slots it has, all that kind of stuff. All that stuff's kind of old-fashioned anymore, right? But a lot of y'all still have desktop computers so that you can game on them. So the specifications for the computer. We haven't listed their attributes yet. Oh, and we're not gonna? Oh, thanks. Alrighty. So, our computer object may need a hard disk size and a RAM size. And if people like to order computers in different colors, you may give a case color, that kind of thing. And you might put a date on it when it rolled off the assembly line. And you might put, an attribute that which version, which operating system it has, so that you know whether you're buying something with Windows 10, Windows 8, or whether you can trick them into installing Linux on it or whatever. So instance variables are the ones that change on a computer by computer basis. Each computer could have a different amount of RAM. Maybe they all have the same, but we don't know that. Each computer could have a different hard drive. Each printer could be painted a different color. Each computer surely has a different serial number, So each computer has a list of traits that are associated with an instance of that computer class. Each one of these is an instance of our computer class. The class lists the attributes that a computer can have, and then the computer itself actually is that collection of information. The computer has the amount of RAM and what kind of processor it is or whatever. So each one of these is an instance of the class. And the terms instance and object get used interchangeably. You say, okay, I'm going to create an instance of the computer class, or I'm going to create an object. They mean the same thing, and the books may kind of vary between one term and the other. But one thing they won't vary from is the fact that variables that are associated with a specific class that change on an object-by-object basis are known as instance variables. Let's go ahead and create a class. Did not mean to launch Visual Studio. Alright, we had this program here, you know, about entering text and stuff like that. I guess we can keep it. We're just going to have to enter some text every time we do anything else. That's going to get tedious. Let's put our code up here at the top rather than at the bottom. So underneath our scanner, that's where we're going to put our code. But firstly, we need to define a class. Let's define a class for cars. You can define a class inside the .java file for another class. But that's generally considered very poor programming. And when I'm demonstrating programming, quite often I want to do it. I want to start typing in a new class right here. But I'm going to try to be good and actually make it in its own file. You should only put one class. Each file should be associated with one class. So I'm going to go to my projects, find my package where my .java file is. I'm going to right click on that and do New Java Class. And I'm going to call that class car. Now I have a class called car. It's in the same package. If I go and look, it's in the same project. If I go and look at my projects now, I'll see that both my .java file there that has the main in it and then car are in the same project. About the time we start doing this and we start messing with more than one project, I like renaming my main project to the word main or something like that, or homework 23, something like that, to make it easily differentiable. Because Java application 23, that's a pretty lousy name. So in my package over here, in my project, I'm going to right click on it and do refactor, rename, and give it a better name. How about main? Or I could call it, you know, October 17 or something like that. But anyways, main will work. Now when I want to edit one, I can double click on it, and then I can edit the other and double click on it. Okay, so what information might we want to keep track of in a car? If you're a used car dealer, what do you want to know about each car?
Make, model, mileage.
Yeah, make, model, mileage, color, you know, all that kind of stuff. VIN number. There's all sorts of stuff that you might want to know about a car, but I'm going to keep the example simple. So, make, like Ford, that'd be a string. Model, like Explorer, would also be a string. And mileage, let's make it a double so that you can say it's got 2,000.5 miles on it. So now we're going to list some instance variables. Instance variables, also known as members, also known as attributes. You'll see all those different terms. Now that I've written members and attributes, I'm just going to delete those two terms and leave it called instance variables for now. Alright, we need a make, a manufacturer. I'm going to just set it to a default value, just in case I print it out, you know. And then let's make a model. String model is equal to default. I could just make it an empty string, right? You know, like that. But I'm going to go ahead and stick the word default in there. And then double mileage is equal to 0. Now I'm going to put a word in front of each one of these that indicates that this data can be changed outside of the object. I'm going to use the word public, and we've seen that before. Public, static, void, main. The reason main is declared as public is so that Java, when it launches the application, can get a hold of that method and run it. Alright, so we have 3 instance variables. Bless you. Year. Year would have been a fun one to put on there. You know, you have a 1998 Ford Explorer. And we can tag that on. Public int year is equal to 0. This is our class. This is our blueprint. We can make a whole bunch of different car objects. So I'm going to go over back into my main method. Also going to delete some of my extraneous.java files that are already open. Way too many of them. Alrighty. So I'm over in main now. I'm going to create a new car. Car C1 is equal to new car. We've seen that syntax before. I was about to ask where have you seen that syntax before, but if you look one line up above it, that's where you've seen the syntax. Every time we create a scanner, we needed a new scanner object. Whenever you're going to make an object, you use the new keyword, followed by a class name. Now, the professional way of naming your classes is to always give it an uppercase letter. Not your variables, not your objects, but the class should always start with an uppercase letter. Are the Java police going to come and arrest you if you don't? No. But if you're working in an environment and you're not following that convention, then people are going to look, strangely at you. Other languages, people follow other conventions. But Java is new enough that the documentation has recommended a convention, and by and large, most programmers have followed it. So new, followed by something with an uppercase letter indicating that it's a class. All right, let's make another car. Car C2 is equal to new car. Now that's not very interesting because if we tried to print out the information about it, it's just going to say default, right? If I do system.out.println C1.model or whatever, it's just going to print out default. So that's not real intriguing. But let's set some information for each one of these cars. I'm going to delete that information. I'm going to say C1.make is equal to Ford. C1.model is equal to Explorer. Semicolon. C1.year is equal to 2012. And C1.mileage. It's been around a while, so 50,000 miles. Let's do the same for another car. C2.make is equal to Toyota. You don't have to use the same things I do. C2.model. Camry. C2.year 2016. C2.mileage. It's equal to, not very much mileage on this guy. 1,000. Now I'm going to move a line a little bit. You see that where I did this car C2 is equal to new car? I'm going to cut that and put it right above the actual stuff that involves C2. See that? So now we have one place where we made one car, and we have another place where we made another car. Go ahead and make a car C3 and a car C4. Same way. Just put in whatever information you like. Lamborghini, Ford Pinto, whatever. So car C3 is equal to new car, blah, blah, blah. Then later on, you're going to have a car C4 is equal to new car, blah, blah, blah. just say. Okay. But I'm going to suggest that we put the display method actually in the car class itself, because we don't have any methods in our car class yet. We just have data. So I'm going to go back to our car class. And these are called instance methods. And let's make one that displays information or prints information. I think I'm going to just use the word print, just like print line, you know. So we do need it to be public, because if it's not public, we can't call it from main. That's not strictly true, but if we made it the word private, it would be. It doesn't need to return anything, though. We're just going to say, hey, print. It's not like whenever you call print line, you check a return value. So that means it's declared as void. And let's call it print. And does it take any arguments? I can't think of any at this point. All right, let's print this guy out. System.out.println make equals plus, and the syntax is going to get rather specific here. This dot make. Now, honestly speaking, at this point, we could leave the this dot keyword off, but I would like for you to get in the habit of using it, because there are times when you do have to. Let's add some more print lines. System.out.println. Now I wish we had added color so that we could say red Ford Explorer or blue Toyota Camry or whatever.
Isn't this just pull it from the main?
It will. When our main set these values, and then we're going to print our object based on those values.
This will always pull from
The current object that we are in. This object's make, this object's model, which is going to probably be different than the other object's make and the other object's model. So model is equal to plus this dot model. System dot out dot println mileage, or let's do year first. Year equals plus this object's year, this dot year, and system dot out dot println mileage is equal to plus this dot mileage. And we could, you know, try to make these things line up all nicely by adding extra spaces and stuff like that. To do that, we probably should have used printf. So that's our method for printing, for displaying. Like that. I can't get it all on one line. If I take the space between the plus and the quotes and the this, it'll all fit on my screen. You don't have to do that. Let's go back to main and print out each object now. So go back to main, and now that we've got 4 cars, C1.print, parentheses in parentheses, C2.print, parentheses in parentheses, C3.print, parentheses in parentheses, and C4.print, parentheses in parentheses. Now when we run it, we'll see our Ford and our Toyota and stuff like that. Now I didn't actually fill in information for C3 and C4, so I'm going to see a lot of defaults, but you probably won't. Make, model, year, mileage, make, model, year, mileage, make, model, year, mileage, like that. So you can see that each object is its own cluster of data about a specific car. C1 was my Ford Explorer. I want to print out its information. I call it C1.print. So earlier I defined a class as being a collection of data and the methods that act upon it? Well, the data are the make and the model and the year, etc. And the methods, right now we only have one, is print. Let's define one more class, which is going to be kind of a geometry class. What kind of geometry-based problem have we done already? Have we done calculating the surface area of a sphere, or we've done that one? Okay. We may as well define a sphere class then. So, along with car and main, I need another class. So I'm going to go over here to projects. I'm going to right click on the same package that has my car.java and our main.java, or whatever you called your new Java class, and this is going to be called sphere. Finish. So check your project to make sure that all three of those files are in the same package, and if they're not, drag the new one into it. Alrighty. All I care about this sphere in this specific case is its radius, because I'm going to add some methods for calculating its surface area and its volume. So public int, why not public double radius is equal to 0. Now let's add two methods. If we're going to calculate its surface area, it needs to return a value. So public double get surface area, or we could just call it area, right? Get area. For now, I'm just going to stick in the words return 0. That's called making a stub. This method doesn't do anything useful yet, but I want to define all my methods and then go back and fill them in. Don't always do it this way, but public double get volume. Return 0. And I kind of always forget which equation is which for the volume and the area. I know that one is like 4/3 something and one is 4 times whatever. So I'm going to Google up the get area function of a sphere, which is a is equal to 4 pi r squared. Okay, great. So for get area, I'm going to declare a variable called area, and then I'm going to perform our calculation. Area is equal to 4 times pi, math.pi, times radius squared. So math.pow, radius to the power of 2. And honestly, I'd rather you make it, instead of radius, I'd like for you to say this dot radius. Now, I didn't do that so I could fit it all on one line, but I'll put the math.pow on its own line, and then I will be able to type this dot radius. It's just a good habit. Is it necessary? No. And then on the next line, return 0. Excuse me. Remove the return 0 because instead we're going to be returning the area, right? Or else it's not of any use. Alrighty. I think I heard the typing slow down. What I want to do next is go back to main and create a sphere and print out its area. So I'm going to go back here, and after my printing out of the cars, I'm going to do sphere S1 is equal to new sphere. Then I'm going to print its volume out. Excuse me, its area. System.out.printf volume of, I keep saying volume, area of S1 equals %.2f \n quote, and then S1 dot get area parentheses in parentheses, and then one final in parentheses. All right, now when you run it, you're going to find out that it prints that the volume is 0. Pardon me?
Go back to the class.
Sure.
Go down to the volume.
Volume's not set up yet. Yeah, guess what I'm going to do? I'm going to ask you to do volume as well. So, but this is the class definition for sphere. I'm going to move the braces up a little bit so that they all fit on one line if I possibly can. There you go. That's our entire sphere class except for one trailing curly brace. So are we good now? I flip back to main? Or you need? Okay, cool. So I go back to main. Here's where I created my sphere. Here's where I printed out its area. When I run it, it's just going to say that the area was 0. What did I forget to do?
Assign a value.
Yeah, I never put in a value. So S1 dot radius is equal to 10. And I've got about 20 copies of the application running. So I need to close them all.
Now, could you pass the radius as an argument?
You can. You could. In fact, that's the preferred way to do it. What we would like to be able to do is to put a 10 there. Now we can't yet. If we did that, it's going to call it a syntax error. But you could rejigger it so it was. Or, and this is the way that the book teaches in this chapter, you say s1.setRadius is equal to 10. Don't type it because we don't have it set up like that. Or I guess we could go and modify it to do that. Yeah, why not? Delete this line, s1.radius is equal to 10, and instead type that line. But we're going to have to go and add that method. So go back, we're going to have to stop pretty soon, to the sphere class, so I shouldn't have done this, and let's add a setRadius method. It doesn't need to return anything. So public void setRadius. Let's make it accept a double as a parameter. Double radius, like that. And then inside there, we're going to set this dot radius equal to radius. Now in this case, once you start talking about the this reference, you start noticing how many times you use the word this. Anyways. In the example we are looking at, we have to use this dot in order to get this to work. Because otherwise, it doesn't know how to distinguish this variable being passed in and that variable, which is part of the class. So that's what this keyword actually means, is that this variable right here is part of the class. All right, so I need to double check it. I need to save everything. I need to run it. And if I can keep y'all here 4 or 5 minutes late, what I want to have y'all do after you run it and make sure that you actually get an area, I did, is to go back and fill in the get volume function. Let's pull up the equation for get volume. So the volume of a sphere, it's 4/3 pi r cubed. I already know that. All right. So the formula for a volume of a sphere is V is equal to 4/3 pi r cubed. But remember that there's no up arrow operator, so you're going to have to use math.pi. And please make 4 divided by 3 actually floating point numbers, or else it's going to do what we don't want it to do, which is round down. And then also remember to put asterisks between everything. But go ahead and try to get that working. And in the meantime, so I'm going to go back and do a solution for this. Get volume ought to look something like this. double volume. Now what should my next line be? Volume is equal to what? Most of it's already there in that comment, but somebody humor me. What's a good formula for calculating the volume?
4.0 divided by 3.0.
Yeah.
Times math.pi.
Times math.pi. What's next?
Times math.
Yeah, times math.pow. I'm going to put this on the next line. This dot radius, comma 3. And then I will return that volume on the next line. Then I want to print it out. I'm going to go back to main, call get volume, and print that out. Can't get all of it on one line, sorry. So anyways, over here in main, double volume is equal to S1 dot get volume. Then print it out. System.out.printf area, volume of S1 equals %.2f \n, comma, volume. Or I could have just called S1.getVolume, right? I didn't have to store it in a temporary variable. Alright, I'm going to run it, see what I like. If I like its output. Alright, and the volume of it is 4,000 units. I guess that's right. I don't know. What if I set the radius to 1 and run it again? The volume is 4.19. I'm going to go back to Google and let it tell me. Enter the radius. If I enter 1, 4.19. Okay, so it worked. And so at that point, go ahead and upload your .java files and have a good break. I'm not going to give any more homework assigned over the break than what we've already got.
Do you want the Java file that from the beginning of class uploaded to?
Sure. I actually put everything in 1, but go ahead, and since you didn't give me 4 of them. Yes, sir.
I accidentally used integers instead of floats when they're calculating the volume, and the results are different. Why is that?
Because 4 divided by 3 rounds down to 1 if they are integers.
Even though you set the volume as a double?
Yep. Because the calculation is done before it's copied into the variable. So all of that happens without even knowing that it's later on going to be stored into a double. So you have to make a 4.0 divided by 3.0 or something, rather than just leave them as ints.